Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The stepped beam of length 4A carries a distributed load of intensity WO over its middle half. The moments of inertia are 1.5 of IO for the middle half and IO for the rest of the beam. Find the displacement of the beam at its midspan. So hint, utilize symmetry and analyze the right half of the beam only. So here's the given figure. So by symmetry, the maximum deflection occurs at midspan. So therefore, the slope at midspan is 0. So there is deflection at midspan, and that's the maximum. So by symmetry, the reaction here is W times A, half of the load. This is also WOA at B. So therefore, the shear at the midspan is 0 because WA minus WA is 0. So we just compute for the positive moment at midspan. So moment at midspan is WA times 2A minus W times A over 2, the moment of the load, the left half load. So moment at midspan is equal to positive 3 halves WO A square. So let's put it there. Then remember, this is our origin. We analyze only the right half. So we extend the loading so that it will be for the continuous, and we counter it with the same loading of WO. So our X begins at the midspan to that section there. So therefore, we can now derive differential equations for portion from midspan to this junction here, and from midspan to, for this segment, the last segment. So A times 1.5 of IO y double prime 1, y1 double prime is equal to 3 halves of WOA square plus WO times quantity x minus A. This is x minus A, the length, square over 2 because WO times x minus A over 2. Then minus WOX times x over 2. So that's why we have minus WOX square over 2. So divide everything by 1.5. So EIO y1 double prime is equal to WOA square plus WO quantity x minus A cube, A minus A square rather, over T minus WO x square over 3. Integrating once, that's applicable from 0 less than equal to x less than equal to A for this part. Then integrating AIO y prime 1, y double prime 2 is, let's go back to this. Let's copy this. This is unaffected because the moment of inertia of this portion is IO only. So this is applicable for A less than equal to X less than equal to 2A. So in this segment here, integrating this differential equation, AIO y1 prime. So that's the slope, WOA square X plus WO quantity X minus A cube over 9 minus WO X cube over 9. Then there is no C sub 1 because, as I said, when X is 0, because the maximum deflection occurs at midspan, the slope of the tangent is 0. So that's why there's no C sub 1. But there is C sub 2. That C sub 2 there is the maximum deflection at midspan. So integrating again, AIO y1 is equal to WOA square x square over 2 plus WO x minus A to the fourth over 36 minus WO x to the fourth over 36 plus C sub 2. We will evaluate C sub 2 later. And when x is 0, this will be 0. This will be ignored because the value inside the parenthesis is negative, and this is also 0. So that's why the maximum deflection is C sub 2 over EIO. But we need to solve C sub 2 later. Then we also integrate this equation. EIO y prime 2 or y2 prime equals 3 halves WO a square x plus WO x minus a cube over 6 minus WO x cube over 6 plus C sub 3. So there is C sub 3 and C sub 4 for this segment here. Then integrate again. EIY2 equals 3/4 WO a square x square plus WO x minus a to the fourth over 24 minus WO x to the fourth over 24 plus C sub 3x plus C sub 4. So that's it. Then, when x is 2a at b, y2 is 0. So 0 equals 3/4 WO a square 2a quantity square plus WO 2a minus a to the fourth over 24 minus WO 2a to the fourth over 24 plus C sub 3 times 2a plus C sub 4. So setting up this equation, 2a C sub 3 plus C sub 4 equals, so make this positive, then minus this value, these are all like terms, equals negative 19 over 8 WO a to the fourth. Then at this point, when x is a, the slope and the deflection is common for this segment and for that segment. So let's begin with slope first. Here, WO, when x is a, WO a square a minus WO a cube over 9, this is 0, equals this equation here, the 3 halves WO a square a, this is 0, minus WO a cube over 6 plus C sub 3. So we can solve C sub 3. These are all like terms. So C sub 3 is equal to negative 4 over 9 WO a cube. Then substitute here to solve for C sub 4, 2a, negative 4 over 9 WO a cube plus C sub 4 equals negative 19 over 8 WO a to the fourth. So we can now solve C sub 4. C sub 4 is equal to negative 107 over 72 WO a to the fourth. Then EIY1 is also EIOY2, EIOY1 and EIOY2 at this point, at this junction is the same. They are equal. So x is a, substitute here first. WO a square over 2. So this is 0. Minus WO a to the fourth over 36 plus C sub 2 equals 3/4 WO a square 0 minus WO a to the fourth over 24 plus C sub 3, which is negative 4 over 9 WO a cube times a plus C sub 4, which is negative 107 over 72 WO a to the fourth. So because these are all like terms, use your calculator there. We can solve C sub 2. C sub 2 is negative 61 over 36 WO a to the fourth. Now, as I said, the maximum deflection occurs when x is a at the midspan, and that is for this equation here. We just set x is 0, so this is 0. This is ignored because the quantity inside the parenthesis is negative. and this is also 0. So AIO Y1 or Y max or delta max is C sub 2. Therefore, we just divide this by AIO rather. So AIO delta max is equal to negative 61 over 36 WO A to the fourth. Finally, delta at midspan is negative 61 WOA to the fourth over 36 AIO. So that's it for this problem.